discuss the next question, number 32. The loop transfer function of a feedback system is g of s h of s is equal to s plus 3 by s square into s minus 3. So this is our transfer function given to us. Take the Nyquist contour in the clockwise direction, then the Nyquist plot of g of s h of s encircles minus 1 plus j0 once clockwise direction, twice in clockwise direction, once in anticlockwise and twice in anticlockwise. So this is going to take a while because we have to go through how to plot a Nyquist plot. We have been given an equation, a transfer function, and we need to find out the Nyquist plot. Okay, so before we go into the actual calculation, let's go over a few basic aspects. So Nyquist plot is another frequency response plot of a transfer function, and it's the basic is actually the same as Bode plot. Both plots are frequency response plots of transfer functions. Now the fact that Nyquist plot can be plotted for only open loop transfer function, while Bode plot can be used for both open loop as well as the closed loop. And to plot a Nyquist plot, we would have to find both magnitude as well as phase. Now that is important for any feedback system given to us. In order to plot perfectly the Nyquist plot or a Bode plot, we would have to find out the magnitude as well as the phase for a particular frequency given. So now for the Nyquist plot, we would need both magnitude and phase angle. We will go over both these calculations, and in order to plot the Nyquist plot, we need to determine the region where the plot needs to be drawn. Now the region is very important because the entire plane is S-plane. Okay, so you should know that the Nyquist plot would be drawn on an S-plane. So let's take this for example here. Now we have this is the j omega axis and the entire plane is S-plane. Okay, so on the S-plane, the region of the plane that needs to be covered, or the Nyquist region, or so that's how it's called, we need to figure out which region covers the given transfer function. And also an important point is that we need to cover the region and avoid the poles and the zeros of the given transfer function. So I'll write that down over here. Need to cover the region of the S-plane where the system is to be evaluated, and we need to avoid the zeros and poles. So the zeros are the roots of the numerator. You should remember that. Zeros are the roots of the numerator and poles are the roots of the denominator. Okay, so look at the transfer function given to us. G of s, h of s is equal to s plus 3 s square into s minus 3. So this means that minus 3 is a 0. So we have here minus 3 is a 0, and for the denominator we have s square, which means that 0, 0. There are two poles over here and the third pole. So altogether 3 poles we have. 0, 0, 3. Okay, so we have 2 poles on the origin, so I'm going to write it over here. So we have 2 poles at the origin, 1 pole in the positive axis at 3 and 1, 0 at minus 3. So basically we need to draw the Nyquist plot around the region in such a way that it avoids all of these three points here. It has to avoid 0, it has to avoid 3, and it has to avoid minus 3. Okay, so this is the general basics of how a Nyquist plot should be evaluated or drawn. Okay, so the next thing is that each of the S term given here must be replaced by j omega. Now by replacing j omega is when we evaluate the magnitude and the phase. So let's start with the magnitude calculation. So we start with magnitude calculation. Okay, so let me write down the transfer function. The transfer function is s plus 3 s square into s minus 3. Okay, so this is what has been given to us. Yes, okay. Now for the magnitude calculation. Okay, we start with replacing s with j omega. So we have here g of j omega. H of j omega is equal to j omega plus 3 divided by j omega square into j omega minus 3. Okay, so this is just the representation of s in terms of j omega. Now to find the magnitude is mod of g j omega h j omega. The modulus represents magnitude, and okay, you know for the complex for a complex number a plus ib, the magnitude is root of a square plus b square, right? So we are going to apply the same thing over here. So we have let's see, root of omega square plus 9 divided by omega square into omega square plus 9. This gives us 1 by omega square. Both of these get cancelled out. So the magnitude of the given transfer function feedback system is 1 by omega square. So in terms of direction, you have to remember a couple of points. One is that if the pole is closer to the origin, we move clockwise. But if a 0 is closer to the origin, we move anti-clockwise. But the question here, take a look at this rough diagram over here. We have 3, we have minus 3. Oh, don't consider the poles that are on the origin. So apart from that, you'll have to consider the other pole and 0 that is given. Now you will notice that minus 3 and 3 are equally spaced from the origin, so we cannot tell which actually is closer to the origin in order to know which way we move. So if a pole is closer, then we move in the clockwise direction. If a 0 is closer, we move in the anti-clockwise direction. So in this case, the question already tells us that it moves in the clockwise direction. The Nyquist contour is in the clockwise direction, and we have also been given how it encircles. It encircles minus 1 plus j0. So let's just see how that works out. Okay, so we have the magnitude 1 by omega square. Next, let's find out the phase angle. So we have the phase angle to be calculated. Okay, so we start with the numerator. The numerator is s plus 3. So s plus 3 can be written as tan inverse of omega divided by 3. So this is our numerator. Minus, now we come to the denominator, s square. Now s square is j omega times j omega. So you should know that 1 by j omega can be considered as a whole half circle. So that's 180 degrees. So 1 by j omega square would be 180 plus 180. So that's a whole circle. 180, 180 is 360, which means it's a whole circle. So one circle is complete, so we can actually ignore that. And then minus, what do we have here? We have s minus 3. So s minus 3 is written in as minus tan inverse of omega by 3. Now we evaluate this. As I said, that 180 plus 180 is 360, which means that for s square it completes an entire circle. So the phase angle would be written, evaluated as 2 tan inverse of omega by 3. We have tan inverse of omega by 3, minus and minus is plus. So we have 2 tan inverse. So now in terms of the transfer function, GH is equal to, can be written as magnitude and phase angle, right? So magnitude is 1 by omega square, phase angle of 2 tan inverse of omega by 3. So this is how the expression is written, magnitude and phase angle. Next we need to find out the values. In order to plot the Nyquist plot, we need to find out certain values. At omega is equal to 0, omega is equal to infinity, and since we have the pole and 0 at 3, let's find out omega at 3. Okay, so here we actually have pole at 3, so we find out omega at 3. So at each one of these values, let's find out the entire expression. So at omega is equal to 0, substitute 0 over here, 1 by 0, let's call it's infinity. At angle 2 tan inverse of, substitute 0 here, so 0 by 3, anyway the whole thing is 0. So that's our first value. Next, at omega equals to infinity, substitute infinity here, we will have 0 and the angle being 180. Okay, 2 tan inverse of infinity by 3. So at omega is equal to 3, we substitute that over here, that's 1 divided by 9 omega square, and the angle being 2 tan inverse of 3 by 3, which is 1. So I guess I can write that out for you here, 2 tan inverse of 1, and that would be 1 by 9 times 2 into 30. So that is 1 by 9, angle 60 degrees. Oh, I'm sorry, no. 45. 45. So tan inverse of 1 is 45, and that gives us 90 degrees. 1 by 9 to 90 degrees. Okay, so this tells us a whole lot. We have the phase angles of 0, 180 and 90. So the values of omega we have taken 0, 3 to infinity. So this tells us that the plot starts from 0 and it goes to 180 through 90. So I'll draw that here. So it sort of resembles something like a very weird shape like so. And it goes as an entire circle this way, comes here. So that is a very rough diagram of the plot. So we have omega is equal to 0 here, omega is equal to 0, and omega is equal to infinity here. Okay, and this entire circle is this region over here, that's minus 1 plus j0. Minus 1 plus j0. That is that's what the question says. It encircles minus 1 plus j0. So that's here. Okay. So what that actually tells us is that it starts at 0 and it goes to 180 through 90. And because it circles in the clockwise direction, it goes this way and then it goes to 180 through 90. So you have to remember that. It goes like so, like so, like so, and then it comes back to the point where it starts off. Okay, and you should also know that since there are 2 poles on the origin, and we have 2 poles on the origin over here, right? 0, 0. So because there are 2 poles on the origin, we will have 2 semicircles. 2 semicircles with radius of infinity. Now you have to remember that Okay, so two semicircles of radius of infinity, and they mirror each other, so they are symmetric. Alright, so they are symmetric, and the direction, it starts from 0 and it goes in the clockwise direction, and because it is symmetric, it stops. The flow of the plot actually stops where it starts, which means that it takes only one, it encircles only once, it cannot encircle again. Now, because there are mirror images of the radius omega is equal to infinity, it will go just once, and that means A is our right option. It circles once around -1 plus j omega 0 in the clockwise direction. Well, I hope this notes is enough to give you a basic understanding of what a Nyquist plot is, or how it can be plotted using the transfer function given to us. Well, I hope this helps.